first member from the IDP2 Section 2 Group 9. My metric number is AE170122.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Untitled Chapter and my metric number is CE170165.
Assalamualaikum and good day everyone. My name is Farisha Husna binti Zaidi and my metric number is AE170133.
Hi and Assalamualaikum. My name is Fatima Izzati binti Hamizan. My metric number is AE170051.
Hi, my name is Hairudin binti Hairudin. My metric number AE170137. In this video, we will presenting the development of grass cutter using IR remotes and sensor. Nowadays, people are being more aware of their environmental surrounding as most of the grass cutter that's available are using fuel or petrol to make them function. This will cause air pollution, water pollution, or even global warming that will increase the rate of environmental pollution. Based on a study, 70% of Malaysian home citizens are using old version of grass cutter machines as their daily routine. The grass cutter of old version are using petrol and fuel that will be not good for our health. Next, in aspect of health, grass cutter, the old version of grass cutter will cause a back pain to the older generation because these activities are consume a lot of energy as not suitable for the older generations. As can be seen from the previous video, the old men who are using the old version of grass cutter machine are having a problem with back pain. To overcome this problem, we developed the grass cutter using IR control and sensor that will easier to use just by using a remote. Anyone or wherever they are, they can just use the grass cutter machine to clean their home for a gardening purpose just by using a remote control. So, I will pass to the next member to present the development of grass cutter machine using IR remotes and sensor. Thank you.
Lawn mowers designed by Edwin Burke have been in existence since the early 18th. Machines for grass cutting are popular amongst workers in agriculture, gardening, landscaping, horticulture, and etc. However, grass cutting is a hard work and can be an arduous task for people who has disabilities, young and older people. They might call for a help from any agencies that provide services such as lawn mowing services, yard cleaning services, and etc. Furthermore, air pollution, water pollution, global warming contribute to the increase of the environmental pollution. Based on the study, it is reported that 70% of nation home citizens are utilizing fuel power grass cutter for their daily grass cutting routine. Lastly, motor as power engine and it require more money to its periodic maintenance. Therefore, electric grass cutter is used to overcome this problem. In this project, the grass cutter using IR remote and sensor is a grass cutting machine that have a capabilities with a remote control. Practical, convenient, well organized and safe are the other advantages for this Arduino grass cutter. The objective for this project are to develop a simple operating grass cutter with the implementation of infrared technology, to design a compact size and portable grass cutter that easy to move from one place to another. Third one is to design an environmental technology grass cutter with a low cost budget. And lastly, to develop and implement anti-vibration mechanism to grass cutter.
Good morning to all the panels. Let me introduce myself first. My name is Chong Chunwa. Now I would like to present the scope of our project. This project is controlling grass cutter by using the IR sensor and remote, which is a very simple communication medium. The project is IR sensor and remote based because it gives a wider range of control and more efficiency. The physical barriers like fence and plants do not affect in controlling the grass cutter. The project aims to design an IR sensor and remote interface, Arduino grass cutter, and write program into the Arduino microprocessor. Whenever a button on the remote is placed, it will send an infrared signal to the IR sensor in the coded form. The IR sensor will then receive this signal and will give it to the Arduino. The Arduino programs contain instructions mediating between the IR remote and the Arduino grass cutter to supervise the motion. A L293D motor driver IC bridge is used to allow a voltage to be applied across a load in any direction. The circuit diagram is set and run by using KinderCAD simulation to test this project thoroughly. Next, I would like to present the methodology of our project. This slide shows the listing of components used in this project in simulation by KinderCAD. One Arduino Uno used as the microcontroller, 100 ohm resistor for diode connection, 1K ohm resistor for cutter connection, 3 DC motor act as the diodes and cutter, 1 IR sensor as the wireless sensor, 1 remote control to control the grass cutter, 1 red LED act as the emergency stop light, and lastly, 1 L293D hybrid motor driver to control the direction of the motor. The total cost is predicted to be 121 ringgit Malaysia and 20 cents. Now, I would like to explain the flow chart of Arduino grass cutter using the remote control. From start, we declare the analog pin of PWM and hybrid L293D. Next, we configure the specific pin to be output. Then the signal is read from the remote control. Now, we need to determine which button of the remote control has been placed. If button 1 is placed, pin 6 is high and the cutter is turned on. If button 3 is placed, pin 6 is low and the cutter is turned off. If button 2 is placed, input 1 and input 3 are high, while the input 2 and input 4 are low, make the grass cutter moving forward. If the button 4 is placed, input 1 and input 3 are high, while the input 2 and input 4 are low, the grass cutter moves back toward left. If the button 6 is placed, input 1 and input 3 are high, while the input 2 and input 4 are low, make the grass cutter move toward right. If the button 8 is placed, input 1 and input 3 are low, while the input 2 and input 4 are high, make the grass cutter is moving backward. If the button 5 is placed, input 1, input 2, input 3, and input 4 are both low, make the grass cutter stop and the red LED will turn on. Next, the value of enable A and enable B is determined whether it has changes. If yes, the speed of the grass cutter will change based on the output value. If no, the signal will receive from the remote control again and the loop is continued. Now, I would like to explain the flowchart of the project design. From start, we design the Arduino grass cutter. Next, we simulate the grass cutter by using the KinderCAD. Then we need to determine whether the grass cutter is able to function. If yes, then the project design process is end. If no, we need to troubleshoot the problem occur and fix it.
Hi, I'm Fatin. I would like to explain about the result analysis and discussion of this project. First, let me explain about the result. Firstly, we need the remote control to control the grass cutter machine. The remote control will transmit an infrared signal. After that, the IR sensor will receive the infrared signal from the remote control. The IR sensor then transmit the signal that it gets from the remote control to the Arduino Uno. The Arduino Uno will give instruction to all components based on the code that we save on it. Next, the L290D H bridge will function as the motor driver to the DC motors. Okay. Now, let's go to the simulation of this project. So, this is the simulation of our circuit. We use the Tinkercad simulator to simulate our circuit. Before I start the simulation, I would like to show the code of this program. Okay, this is the code of this program. This part will define the pin of the Arduino Uno that we use. Next, display of 15 to 17 line about the LED. After that, at line 20, we start the void setup. In the function, the serial begin and start the receiver. For motor wheels, we use the enable A, enable B, input 1, input 2, input 3, input 4, and LED as the output. Enable A for input 1 and 2, and enable B for input 3 and 4. Okay, we go to the loop. In this loop is for the infrared signal received from the remote control. When we press the button 1, the cutter will on, and when we press the button 3, the cutter will off. When we press the button 2, the grass cutter will go forward. When we press the button 4, the grass cutter will change direction to the left. When we press the button 5, the grass cutter will stop and the LED will turn on. After that, when we press the button 6, the grass cutter will go to the right. But for the button 8, the grass cutter will go to the back. This code, that's all the overall code for this project. So now, I will explain the circuit diagram of the simulation circuit. This is the remote control that will transmit the infrared signal to the IR sensor that will receive the infrared signal. This is the Arduino Uno board that have the code in it, and this is the motor driver, which is the H bridge. This is the motor 1 and motor 2, and this is the motor for the cutter. Okay, I want to explain more about this H bridge function. This part is for enable 1 and 2, which is the enable A, that will enable the input 1 and the input 2. The input 1 and input 2 will go to the Arduino board, and for the output 1 and output 2 will go to the motor. And this is the part of the enable 3 and 4. The enable 3 and 4 is the enable B that will enable the input 3 and the input 4. The input 3 and the input 4 will go to the connection of the Arduino pin, and the output of the 3 and 4 will go to the motor. And this is the cutter. The connection of the cutter will go to the pin 6 of this Arduino Uno board. That's all from me. Thank you.
I will explain our group challenge to complete the project during MCO. First challenge is limited communication between group members. This is because some of us have line internet connection issue. So sometimes they had some information that misheard. This issue also make the group member and supervisor unable to perform proper discussion. Second, hard to implement IoT in the simulation project. This is because we unable to find any simulator or software that can do simulation of IoT without having the hardware. If we want to implement IoT in the group, they must have the hardware for their IP address. And the last challenge is challenge to do project from simulation to hardware. All the group members stay far away from each other. It will be hard to do the hardware alone. Other than that, limited of tools and components at home also had made a reason for this challenge. Next, we will show about the short demonstration of our project.